Hi there. This will be a live programming session. I will be working on one of my Rust projects. This is CSS Structs. It's a Rust parser for CSS that parses CSS from textual string content and represents it with abstract data types, basically a couple of structs. Let me show you what I have right now. The project is already in a semi-working state. Basically, this is the highest level usage you can imagine. You have some style sheet as some kind of string content and you parse it. This parses the whole style sheet. You also have individual structures that are not a style sheet as a whole, but decorations, decoration lists, values, etc. And you can also create style sheets programmatically and then parse, convert them to string or use their values as abstract data types. So if I run this right now, this main function yields the following. You see we have just print a text parsing demo at the top, and then we print the entire style sheet. It has format debugging trait, and we get this OK result as a style sheet, which is a vector of rules, and rules have a selector, which has decorations. Let me zoom in. That's a decoration list, which contains a couple of decorations. And each decoration has a name, in this case padding, value, and important, which is a Boolean value. I am making this entire thing because I'm using it. I started writing this SVG optimization utility in Rust, which I plan to create. I am creating from scratch to optimize SVGs in the best way possible. And I also plan to create a public API for it and also package it as a standalone desktop application, native one. Now, this initially was a part of the ESVG package, which I'm making, but I decided to separate it into a separate Create Rust project because it's useful on its own. And there are some other solutions for CSS parsing, which weren't exactly to my liking, although admittedly they might be more developed and handle more edge cases than what I'm currently writing. Still, the current situation is that at first, this was a regular expressions implementation, and I went ahead and rewrote it. This is the decoration part. A decoration is the most granular item in my CSS parser. It's essentially the struct that contains a name, value, and important boolean. So a single CSS decoration is represented with that. And I rewrote it with num. In order to avoid writing a lexer and like a parser from scratch. Num, if you are not aware, which I wasn't, I just did a lot of research to use a library for parsing that's performant, has a good API, and would allow me to start almost from scratch and not have a serious performance impact on my application. And num is a parser combinator library. It tries to be zero copy, so the performance overhead should be minimal, which I like. And it's basically a combinator library, meaning that you create these small parser functions and then you can combine them into larger structures. And this way you create these more complicated parsers. And if I zoom in a bit so that you can see, the basic example is for hex cover, which basically uses this parser, hex primary, and then hex cover. So these two parsers are basically, this parser, hex cover, uses hex primary multiple times. We get red, green, blue by using hex primary 3 times and parsing the input. And that's essentially how my CSS parser is structured. It's a little bit more complicated, just a little bit. Parsing CSS is not that hard, admittedly. So I tried to have the cleanest architecture possible. And that, in my opinion, for this case would be this struct has a couple of methods. First of all, we have a couple of parsers that are private methods used by this CSS declarations parser. As I mentioned, nom is not the nom library is best used if you create small parsers, which you can then basically compose into a larger, more complicated parser. And in this case, we're parsing a declaration which contains an identifier, which would be if we say color red, an identifier would of course be color right here. And this is the parser for that part. It basically takes the first character, which can be any sort of letter, underscore, dash, or non-ASCII symbol, and then parses the rest of the characters, which can be anything else, including a digit, like the same set of items, including a digit. We cannot start with the digit in CSS, basically. And that happens with a few internal ready-made combinators and parsers in nom, which are take, while, one, take, while, and despair and recognize. And we just map this to a string. This is basically what a nom parser looks like. And this parses our identifier. Then we have a value parser, which is for the value after the identifier. As you can see, that also parses the important and returns a value which is a tuple of string, that's the value, and boolean for the important. And these two are combined in another private function, which is parse declaration. And that parses an entire declaration. It combines these two parsers. You see separated pair. Here we see nom much better because it's a larger thing and you can imagine it. A separated pair is a CSS declaration that's delimited by multispace, 0, the character semicolon, and multispace 0. And on the two sides of that delimiter, we have the identifier preceded by multispace and the value. And we pass these two parsers to parse the entire declaration. And these are all private functions that will later be used in the public facing API of CSS declaration. I also have this create public function. So if you're not aware, I actually didn't know that, and it's great because I'm writing a library, and this public function for the create is awesome because I want the parse function as it returns this iResult, which is a nom result. It's basically a kind of like the result type in Rust, but it also returns the unparsed leftover string and the CSS declaration. And as it's a nom internal, I don't want my clients, API clients, to access it, as they shouldn't care about nom. It's an internal library used by the parser. They will be clients only of the actual parser. And that is public to the crate only. So I can use it in this crate in other modules like the CSS declaration list, but not any API client cannot use it because he has a couple of public functions. For simplified API, he has new, pretty standard to create programmatically a CSS declaration with name, value, and important, and from string, which is to parse declaration. And I, of course, implement the display method so that they can convert to string or print or whatever. And that's pretty simple. It's with formatting. Two cases for important and without important. And I have a very comprehensive testing suite, which might be too comprehensive. Some of the cases might be covering each other. Might be unnecessary because I have over coverage, but that's better in my opinion. I might check these out more systematically and remove some of the test cases. But for now, I believe I cover most of the edge cases in CSS. And we, at least for the declarations, of course. The other modules are not that developed. I have worked on that a lot during the past few days, and it's much better. I also had this documentation comment at the beginning. so that you can see the main API examples. And the good thing about this is I really like doing that. As you open the file and you can immediately understand the entire API and structure of this code. Plus, with Rust, what's great is if you run cargo doc or if you publish this, you have a pre-built documentation. And that's a lot actually. Um, Let me just open it so that I can show you. I'm in home, CSS Structs, target, where we build. We have doc, CSS Structs. There we go. And here I open the index. And if I open the CSS declaration module, I have this documentation right here, which is exactly generated from my comment right here. That's very powerful and it's great. Like you can't take this for granted, especially if you've used older programming languages and build tools, and you understand that sometimes you have to set these documentation systems up, or in the past you have to write this documentation in some way or the other. And yeah, it's great that this is built into Cargo now. Okay, so without getting sidetracked too much, I just wanted to get you into the project a little bit. Here's where I'm at. I mean, the other modules, besides the declaration, is in a very good state, and I have the API I wish to have for all of my modules. Basically, I want the client to have new from string and format for any structure in the CSS structs package, so that he has a consistent and simple API to use. That should be enough for pretty much any case he might need the CSS parser for. Of course, the struct properties are also public because he'll use those after he parses his file. And I want the same consistent API and test coverage for my other modules, but they don't have that because I have been working on this for a few months. And as I mentioned, this was originally regex based. Then I rewrote it a couple of times, so we have inconsistencies here, including the fact that I was learning Rust while writing this. So you will see a lot of mistakes. Not that this probably still has mistakes and I'm still learning Rust, but it's much more mature than the other code. And I want to go through the other modules. I have declarations right here, which are the most atomic part. Declaration list, which is a list of declarations. I still don't remember why that exists, to be fair. There was some reason why it's not just a vector of declarations, but maybe if I open the file, we'll learn that, but I want to focus on something else now. And rule. And rule, I think, is, yeah, a selector and declarations. I mean, these follow the naming convention in the CSS specification. Basically, although sometimes I get messed up with that too, although I'm writing CSS for like 15 years or something. And these are the three primary structs. The main file is just the demo. I think right now it wouldn't even be included. And we have style sheet, which a style sheet is what? It should be many rules, I believe. Where's the struct? Yeah, a style sheet is a vector of CSS rule, which is normal. So the question I had was, why do I have declaration list? And declaration list has declarations, which is a vector. It parses these. Yeah, that's why I need to have it. Otherwise, the parsing has to happen. If I don't have this module, the parsing has to happen in rule, which I don't want, essentially. And here we also have an extra API. We can remove a declaration, as you can see. But if we have this rule to remove a declaration, why do I need that, considering I can just access this and modify the vector as I wish? Yeah, I don't think that's necessary. It absolutely isn't. Although there is some logic for retain. Yeah, I might add that. I might keep that actually. Otherwise, you need to write this basically. Retain code, which isn't bad, but why not? It's a useful rule to have. Function. Oh my god, I'm messing up some words today. I'm sorry about that. Okay, so this is why we have decoration lists. It is a vector CSS decoration, but it also has the parsing logic. Okay, now let's see how we can refactor this so that it's closer in meaning and syntax to this thing. Um, Now, first of all, here we derive the book one partial equal. I can see that the struct is okay. Not much to do here. The implementation. Parse declarations takes an input of string, returns string, and CSS decoration. That seems pretty standard and good. Now, the parser itself parses many delimited with leading space decorations that are delimited with a semicolon. Well, that seems okay. I was just thinking about that, but yeah, that's an okay logic essentially. And we have this parse input at the end. I am very fine with that. Now, the from string method currently returns result, and that's the public client method that parses decorations. And it returns itself with decorations. Now, this is okay. Absolutely, yeah. And I map the error and return string. That's exactly a string error. That's exactly what I do uh, in the other module. Let me see, from string, with the only difference that I do not return the error, but a hard-coded message. I don't know which is, obviously returning the error is better, depending on what the actual error from num is. I think I need to test that to be absolutely sure. But for now, I would go with the hard-coded string approach until I'm sure what kind of errors num returns. Because obviously, you want to return the exact errors from num if they make sense to the client when he uses the API. If it returns some parser error that is not understandable, it wouldn't make much sense. How to parse CSS declarations. Yeah, essentially, that should just lead to some investigation into CSS validity, which this parser will not be the best CSS validator in any case. You can use a CSS validator that's better, including your language server, but it should point you in the direction that the CSS is invalid, and that should be enough. So I'm happy with the static error for now. And that is a public API from string parser. Now, what is this? That is interesting. Why does this function exist? It essentially takes a string and returns a CSS declaration list. Input self parse declarations. So it calls the parse declarations with the input and returns a result. So, yeah. So here I have two functions from string and from str parser. which is essentially a similar approach to what I have in CSS Decoration, but I have different naming. Here I have Parse, which is the public create function, and I have from string, which is the client facing function. And here from string uses parse. And I'll follow the same naming here. I'll just cut that so that I order my functions from private to public create to public. And I'll rename this to parse. Here we're essentially parsing the CSS decoration list. And I need to also grep later and replace any references, although the compiler will also show me. And here, let me just check. I parse CSS decorations and input. This, let me see, why does this have an error? There's an associated function from string with a similar name. That's very interesting. I don't see, honestly, what it means. Here the result is self and string. That's exactly right. Except I don't need to parse decorations, I can use parse. I mean, that's even not necessary. Whether I call that or this is the same thing. In fact, parse decorations is better because we don't have to just call one subroutine more. It's flatter structure. And I think that I'll make that change here as well. Why do I call parse here? Is there a reason? In fact, let me move that closer to this because it makes sense. Okay. I don't think it makes much sense. Yeah. This is just slower. Both are getters to a large extent, and it doesn't make much sense to. No. Here we create the CSS declaration. Okay. So in this case, it makes some sense to have it. Because the declaration creation happens here. And why doesn't it occur the same way here? Because I created here as well. Let's be consistent in that case. I'll just parse. And do that. What is the error? There's an associated function. I don't understand. Where is it associated from? That seems weird. Yeah, from string parser not found. That's clear. Let me look for that function and where it is used. Right here. I can just do that in CSSRule. And now, does that fix all my errors? Kind of. What about here? Decoration list should have, oh yeah, of course. Snake case. I still make these errors when working with Rust. To be honest, I really like snake case. It's much more readable than Camel or Pascal. Yeah, it's very readable and I really enjoy writing it. And I like that Rust enforces it. That's a great decision in my opinion. To not have code bases with different casing because that's just hard. So let's see where we're at. Public create is the parse function. That's great. And then we have a from string, which is a client-facing function and returns the decoration list. remove declaration, which was this helper. I can have that right here. I am still debating the usefulness of this, but why not? It's not something that bad to have. It's not like bloating the code base. It's already very minimal. This I have to remove. At that time, I didn't know that I can just implement the formatting trait in Rust to have this toString functionality, the format display. So let's do that. I'll just copy it from the other module, as the syntax is kind of like shit. Okay. I need to import std format, right? Yeah. Let me go to the top. Okay, format. And yeah, I need to implement this trait for CSS decoration list. And now the formatter would be quite simple. Here we have self formatter result, and I just have to copy this logic. I'll check it in a second. I didn't check what it is. It's some kind of iterator. What's the issue? Expected enum result, standard format error, found string. Wait, here. Let me just open this because my OSP got a little bit buggy. Here I write. Okay, yeah. I take F and all right, that seems cool. Let me see. Is the right macro? Well, seems to me like I can just do. I might go to 4 spaces. Right now, my syntax is broken. I should be able to fix that now, right? Okay, what's the problem now? Unexpected token. What kind of unexpected token? So I have, let me see. Oh, yeah, I can't use it like this. Come on. I take F and yeah, okay. Let me just define this. I'll call that list string, and it will be exactly that. Let's add a semicolon here. And this is what we return. Okay. No OSP errors now, and I can remove string. Okay. And we have the remove declaration item finally. Now, 2 spaces before the tests. Let me see, do I have? Yeah. Here I use items from the crate. Besides that, I think everything is fine. Here in tests, we have a couple, not enough at all. I usually use AI to generate tests more in a quicker manner, and we'll see that in a bit. Now, let me first compile this. I will also run it and run the tests I already have. They're all passing, thankfully. Also, let me run it again and check out the results again, real quick. Everything looks all right. Let me first start by expanding the testing suite. Okay, we have single item. Yeah, it tests if it's there. That makes sense. Multiple items. Some extra white space between the items in a list. No trailing semicolon. Handles it quite well. Empty input. To string. Yeah. And remove declaration. I think that actually covers most of the API. It absolutely does, by the way. The only thing it doesn't cover, it covers the client-facing API. I would like to write some unit tests for the parse decorations item as well. So to do that, I'll just prompt cloud and give it the whole file as reference. And then ask write unit tests for now. We won't just paste these, of course. We will review what it suggests, some edge cases, and add the tests which make sense. It's important for me to have test for the actual parsing function because it's the most atomic item. It contains the most logic out of the entire module. And here we have some tests. Let's see what they are and if they make sense. Single declaration. I mean, we basically have that. Multiple. No trailing semicolon. We have that as well. Mixed semicolons. That's a good one. Leading, white space, trailing white space. Empty input, white space, only extra semicolons. That's a good one. Although, yeah, let's see how it handles it. New lines and tabs. I like this. Partial parse and single semicolon. Okay, let's copy these. These are good. They cover many of the other cases which might not need to be here, like test single. Let me just indent this well. Okay. I need to add some spacing here beneath the items I pasted. Test single, I think. Yeah. Here we have unused items. So let's fix those. Let's see. A few more items. I'm just scrolling fast, relying on my LSP client to show me a warning at the line numbers, and there doesn't seem to be any. Now we might remove some of the other tests, but let's run these first. We have a couple of failing. Parse decoration extra semicolons. I was expecting that to fail. Partial parse. So what's a partial parse? Extra content. Yeah, I absolutely expect this to fail. I do not want this to work. At least right now, that's not an implementation I care about. Yeah. That should currently fail. So I'll just prompt quote, rewrite this test. I expect this to fail. rewrite this test. Oh, wait. I'm actually wrong about this. Let me just check. What exactly failed? Left? Right. Yeah, it did not fail. I was thinking about the entire structure. While this will actually work because it's non-based and it will actually parse correctly that case, even now. I just have some white space in the actual thing. Yeah, and I don't expect to have this white space here. Um, I guess you could check like this as it recommended, or I can trim that. And then we have extra semicolons. That's probably wouldn't work. Let's see. It left some comments here. So we have extra semicolons here. The test expected 1 got 2. Where do we expect 1? Declarations length expected 2 got 1. Yeah. I'm guessing it failed here. This. Hmm. So why is that? Let's go to the beginning. Many delimited. So the second item that should work in theory. I'm thinking about it because it's delimited by the semicolon, and it actually produced a single item, not 2 or 3, just 1. That's a little bit weird. Hmm, that's very weird. And what did it produce? Let me actually show them right here. So it produced color red, false, which is the first thing. Yeah, it did not go to the second one. Interesting. Hmm. I actually don't understand exactly why that happens because it should take many delimited values based on this character. So it should take 4 possibilities in this case, as we have a couple of semicolons. The empty ones will be just empty strings, so it should discard them. And then it should take the 2 valid values. At least that's what I believe, but it doesn't seem to do so. So I might ask out for why does this not parse extra semicolons? So let's see. It might have an idea. Consumes the first. Yeah. Oh, of course. The next declaration starts with a semicolon. That's exactly right. I forgot that it consumes only 1 semicolon. That is likely why. And preceded. Skip empty semicolons before parsing declarations. Well, let's think about that. Mm, It gives me two options. Yeah, this isn't valid CSS syntax. It makes that point that my parser currently is reasonable, and I agree with that. Yet, I would expect it to work in this basic edge case, I think. And it's not that bad to have a safety net for an extra semicolon left at the beginning. That's not uncommon, and it's not that big of a deal. In fact, most production parsers and browsers would handle that very gracefully. And I like that test. And the two options to fix that is with preceded many semicolons. That's fine. That's a good option. Or I can use separated list. I don't know what that does. So let me see what that does first. Um, I mean, GNOME has a lot of combinators. Function list zero. Is it like this? Yeah. Alternates between two parsers to produce a list of elements. This stops when either parser returns error. Um, I guess I kind of understand. So we have a separated list of, let me zoom in, of tag this and this. So two separators here. And we get a vector of them. Here, okay. And how do we use that? We use that. No, I don't like this implementation. This is more robust in my opinion. It's not a bad check to have. So I have preceded many zero. I will not copy the whole thing. I don't want to. Um, Let me see. Preceded. Let me put that delimited. And then we have this line right here, which I'll paste. Many zero, delimited multi-space character. Great. I like that. Now we need to import preceded, which is what we need to check because this is a sequence. There we go. Okay. Test again. And we pass everything. Now, let me check. What state are we at? We pass all of the tests. Out of these, let me just check. We have some which are duplicating from the end user tests for to string to from string single. These are kind of duplicating with the parser tests a little bit. So I could remove them or keep them. But for now, I'll keep them. I might reevaluate the tests more before a stable version 1. For now, it's okay. I prefer to have a more robust testing suite right now. And then we have CSSRule. Now, let's just take an overview again. We have declaration list, and then CSSRule, which is a selector and declaration list. By the way, I forgot this comment on top of the declaration list module. So let's do that. I'll give it an example. Here's an example. Write one for declaration list. Let's see. It should have the context still. I mean, for comments using LLMs is generally okay. As long as you read them, don't just paste them. They just save some time. Let me see what we got. Okay. I'll copy that and edit it in New Vim because it's more convenient. So some of this I will obviously remove. Let me just, sorry. So CSS Decoration List Parser, this module. Yes, that's a good example. I like it. The main API section from string parse, that's not for here. That's not public facing. Remove declaration. Don't we have new? We don't? Really? I want that for completeness. Yeah, definitely. Um, I'll have it right here at the end. It should create a new empty decorations list. Yeah, absolutely. I mean, in this case, it might not be very useful, admittedly, because we're passing an entire vector of things. So it might only be useful in cases like the other module. Maybe that's why I decided not to include the new method here. Here we have a new method, but it's basically a basic constructor where you can pass 3 values and get an end result. Now, for API consistency, it doesn't hurt to have this. It's not too useful. It's just a shortcut. And I'm okay to remain consistent to add this. I just add this small chunk of code, which might be a little bit useless, but it keeps consistency. And it's not that useless because you can keep writing this and just write CSS decoration list new. So that's something. That's something at least. It initializes a new empty vector. Okay. Now, with that, let me just check the comments again. We have a new property. In fact, let me see how it was documented here so that we have consistent documentation. It was second after from string, which is correct because the from string is the primary usage point. Here, I'll change that. Great. Remove decoration by property name and the display trait is implemented. Here we have examples. Parse. Great. Create and modify programmatically from string. Handle various. Yeah, that's not necessary. Let me just see. Right here. There we go. That's an example for the new method. Parser behavior optional. Yeah, that's necessary. All right. I will also check that by running cargo doc and opening the documentation. Looks good to me. And here we have a comprehensive documentation for the methods and everything we need to know about them. So that's quite good. Restricted visibility. Isn't that module public? It should be. It might still be restricted. I believe I declare my modules in main. Yeah, I should probably do that. Let me check. Structs? Yeah. Okay. So this should all be public. Except helpers. And here I use that module. Okay. Let me now just check real quick. Helpers, yeah. Okay. And we have a main function. I would delete the main function, of course. Great. So I have to apply this. Let me just check the time. Okay, I'm still on time. Still have a couple of minutes to check my CSSRule module. Here we have a similar situation, old code, a relatively old code, a couple of months old, with a couple of rules. A CSSRule has a selector and declarations. As you can see, quite straightforward. We have a new method, which is great. Nothing to say here. Pretty much. Like that. It's public. But we have a from string that does many things here. It's the actual complete parser. Because and it returns I result. Okay, we need to split this a bit. So first of all, this code parses a rule. How does it parse it? Delimit it by character. Yeah, that curly brace. That makes sense. And it parses the declaration list. But wait, how does it take the select? Oh, we have a selector parser on the other end. Terminated, take until. Okay. Okay, so this will be quite straightforward. I will write a function. Parse selector. Did Copilot catch this correctly? I'm not sure. So I'll copy my implementation initially. It's terminated by, yeah, paste that. So I have my input selector and I return that as a string, selector trim, and input, of course, as the first item in the tuple. That's the leftover code, which I will need. So here I can say input selector, self parse selector input. Okay, a little bit better. Then I parse declarations. Why do I parse declarations like that when I have the declarations list should be able to handle this? So I should be able to just use that. Except I have terminated here. You know? Let me see. Does declarations handle this? Not at all. Okay. Parse. I won't call it parse decorations because I have that. I'll call it parse decorations block. input string CSS decorations list, and that I don't know what Copilot called here, but that is the actual code. And I like to separate my return with one line for clarity. Here we have input and decorations, which we get and return. And here now I can do input decorations. Here I shadow input and redefine it a couple of times. And that's completely fine in Rust. Yeah, no need for a comment. You see what I do here. Parse selector, parse decorations block. And then here from string, we return iResult. I don't want that. That should be the parse method. Okay. And that parse method will return CSS selector trim to string. Why? I mean, that's completely unnecessary because selector returns string. Or not. So here we return selector trim to string. Here selector. In parse selector we return string. And selector is selector. I can use shorthand, yeah. That's correct. CSSRule selector declarations and the input. And that is the parse function, which will not be public. That will be public for the crate. And then we have the public from string function, which will return parse input, except not exactly like that. I will return result only, which will be CSSRule and string error. Okay. And here, let's copy how we handle the errors. So here, let me just go back. I have the leftover result and the CSS and the rule. Okay. And a possible error. So I map that. Failed to parse CSS. And I return OK CSS rule. That is consistent with our API so far. All right. And I have a new method. Now the last thing to do is to check from string and where it's used with grep. Too many places. Let me just check with CSS rule from string. Here in the actual code, somewhere in, what's that file? Style sheet, and then in tests. Right here in this file. So let's first handle the tests. CSS rule from string. Replace that. Okay. And now let's see the last leftover item. There we go. I'll check if that is even, that seems like a public method. It shouldn't be, but let's focus on this file now. Okay. What else? We don't have a toString formatter. Let's check. Public to the crate. Overall, I'm happy with how it looks so far. Let's import std format, write a formatting function. I'll copy again this implementation because I don't seem to remember it all the time. Let's paste it right here and implement format display for CSSRule. How would I implement that? I guess it needs to be the following format, kind of like this. Let me just see the syntax of that macro. Yeah, it's pretty simple actually. So basically, we have a placeholder here and a couple of escaped escaped items. This one, new. I don't know if I need a new line here. Let's not add a new line for now. And here we have the list of items. So the first thing will be the selector, which will be self selector. Then will be the self declarations to string. That will help. And yeah, absolutely. I can remove that. I have an error, of course. I'll check that in a bit. Let me see. Unknown character escape. Oh, okay. Curly braces are escaped like this. I didn't know that. It's strange to me, but okay. And that should work. Quite simple. Now, the next step, build. First, okay, that's a very good. The good thing about Rust is that if you make a mistake, in most cases, the compiler will tell you before anything else. Compiling Rust is tough if you make a mistake, which is the great thing about the language. The compiler is great. And now let's take a look at the tests. The current tests, basic rule, rule with white space. And all of these are very repetitive with other rules we have, but others are not, like empty declarations, um, new lines. All of that should work. Let's run the tests first. Current tests. All right. Well, let's start from the parse selector. Write tests for this method. Might be a little bit overboard. Let's see what it got. Simple element, class ID, complex selector, spaces, leading spaces, trailing spaces. Yeah, just spaces is fine. Both multiple classes, attributes, pseudo, descendant. I won't add all of these, only a couple of these. So I'll start with the basic cases, class ID, complex selector, and spaces. These we will add right now. Okay. Here we don't have parse selector, of course. Well, it expects it. This is CSS rules parse selector, right? CSS rule. Let's do a smart replace parse selector. And I'll replace that with CSS rule parse selector. Okay. Any errors? None. And let's go back here and see more test cases which are meaningful. I want that leading, trailing, spaces. That's crazy. I mean, spaces is enough. Multiple classes, not really worth it. Now the attribute pseudo is good. Attribute and pseudo, let's add these two. Okay. Any more? Descendant, not really worth it. Child combinator, adjacent selector, general sibling. These are I like. Empty block. New lines is good. Universal selector also. No opening brace error. Yeah, these are fine. With tabs. That's also fine. Yeah, most of these are actually useful. I would say, yeah, they are not, they're very comprehensive, but that's not bad at all. I mean, that's what these unit tests are for, to catch weird errors, weird or obvious errors with simple assertions. And I have quite a few, but that's good in my book. Let's now replace again that syntax parse selector with CSS rule parse selector. Okay, let's test again. 98 tests passed. Good. Now, it's good that we passed all of these. The next step would be to improve the documentation a bit. Let's again generate. I'll use an example again because I don't know if Qualt has the context. Generate a documentation comment for the top of the module file, like this example. For rule. Okay. Yeah. Let's see what we have. Again, we'll remove some items and read it so that it makes sense, because we don't want to mislead people with just generated bad documentation. I'm just using LLM for assistance when writing this. Yeah, these are very good introductions, by the way. This gives you an idea what this is going to be about. From string, new parse, display. This is exactly how a client would use it, except parse is not public. It's only public for the crate. Examples, rule declaration, list declaration. Now the examples get a little bit more complicated here because, and not complicated, but they include more modules as we go along to a higher level abstraction. We have from string. That's great. We have how to create programmatically with from string. Handle, that's not necessary. Yeah. And this about parser behavior is not necessary. This might be documentation on the top level of the module, not on a per module basis, I think. Okay, let's build finally. Test. Awesome. Well, let me see the time. Okay, I think this is a good place to wrap this session. So I had refactored this off camera the previous day. Now we refactored declaration list and rule. And with that, we have declaration lists, and rules in a pretty good shape, I think, with good testing coverage. Although I need to review the tests again. That's something I will do very carefully. Now, what's left is I have this helper, non-ASCII. I might write a simple unit test for it. And finally, this style sheet module, which I need to do the same treatment for. Besides that, I need to remove this main demo, package this properly as a library, and check the documentation, add more documentation if needed, and publish this as the first version, basically, that's beta and ready for use, which isn't the case now. I generally think it's pretty good already with all these test cases covered because it parses a lot of common CSS scenarios and many edge cases. It might not be absolutely 100% complete and handle all edge cases, but I will need to create a more comprehensive test suite for that. And I can absolutely do that. I'll just take the CSS specifications and go through different scenarios one by one because there are many edge cases in CSS, but the basic functionality is quite simple to implement. Okay, yeah, these are quite good. Well, with that, I think, again, I'll wrap this session. If you want to see this code, the project is in my GitHub, linked in the description, absolutely open source. If you want to contribute or have any ideas, by the way, because I'm not a specialist in parsers, lexers, or any of that. This is my first attempt to write something like this. I'll be happy to hear your suggestions in the video description, or open an issue or a pull request, whatever. I'll take a look at it. I'm very interested, and if you want to contribute, you're absolutely welcome. Yeah, with that, if you like these sorts of things and other videos about Rust and about programming sessions, software reviews, don't forget to subscribe to get notified when I release another video. Take care.